welcome or welcome back to our channel. In today's video, we'll be solving a problem which says rat in a maze. And this problem is from GFG and it's of a difficulty level of medium. And now we'll check what the problem statement says. So the problem statement says that we will be given a matrix which will be of an order n cross n. And in this matrix, we have to start a traversal from 0 position, and we need to go to n minus 1 position, right? So see this matrix, it is given to us and it's a matrix of n cross n size, and we need to start from this position. I need to go to this position. We need to find the feasible solutions. Now what will be the feasible solutions, and what the problem statement says is we need to keep as an output of all the possible strings, which says that from this starting position we can reach the final position. Basically, where 1 will be given, we can go to those positions, but 0 will be given, we cannot move to those positions. Okay, so see, if we are going down, we will be using D. If we are going right, we will be using R. If we are going left, we will be using L. And if we are going up, what we will use? We will use U. Okay, so this is a problem statement that tells us. Let us understand this problem in more details now. So what you're going to do is, imagine this is the matrix provided to us, means the exact same matrix like this one, only I have printed it in a broader aspect. So what will be what can be the possible cases? See, this is the directions what we will be using. If you are going to the right, we will gonna use here R. So we will be using here R, right? And if we are going to the down direction, we will be using D. If we are going to the up position, we will be using U. And if we are going to the left, we will be using L here. Okay, so this is what we're gonna do basically. Now let us check what will be the possible cases that we can do while solving this problem. So from this position 1, we can go here down. Then what we can do, from this position we can go here. So this is we will be using R for right. Then from here we can go down again. So what we got, the things we got here were firstly D, because this was the case, D. Then we went R. So this one was the case. Then we again went down. So this one was the case. Then we again went down. This one was the another case. Then where we went? We went right, and then again right. So then we went right, and then again we went right. So this one was this is one of our feasible condition. And now checking for the another feasible condition, what we can see is, here we can go down, right? So yeah, we can go down. Again we can move down because 1 is there. After moving down, what we can do? We can go right now. See, because we cannot go down, and in left there's no such cases. So we can go we can go here to the right. Then where we can go again down. Then after going down, we have only 2 places left, right and right. So this is our another condition. So our one solution is D D R D R R, and another one is D R D D R R. Now go and check it out here. See, this is our conditions, right? So now how to solve this entire problem using backtracking? That is our main issue, how we can solve this using backtracking. So basically what we're gonna do here is we will we'll create a function where we will pass our starting index. So our starting index will be it will be at 0, our row count will be at 0, our column count will be at 0. So we'll be starting it from 0 and 0. Okay, then we'll pass an empty string, and in that empty string what we're gonna do is we're gonna add the resultant strings that we are producing from here, D, D, R, R, anything such. We will just keep on adding those things to our empty string. So let's check how we can solve this problem using backtracking. As in the initial position we are here 0 0. Then what are the cases we have? We have D, L, U and R. So here we will check like where we can go. Either we can go down or we can go right or left. Like we will check the position. So here we can see it clearly that we have one option. We can go where we can go down. So basically while starting from here we have four different conditions. Like we can choose any of them. Either we can go down from here, or we can even go left, or we can go upward direction, or also we can go to a right direction, right? So basically what we are seeing that here only one feasible condition is here, so we will go down. So while moving down, where we went right now, see, this was our place. Now we went where? We went R0. This index is our 1 and 0, right? So this is 1 and this is 0. So we went from 0 0 to 1 and 0. And what will be added to a string? We will add d to a string, right? So here what we're going to check is, while we went 1 0, from 1 0 what are the feasible conditions? Again we will check like from here whether we can go to D or to L or to U or to R. So we will keep on checking in such a way, right? So now what you're gonna see is, again we can move to downwards. So D can happen. So we can again move to D, right? Now we're gonna see that what is our position? It is 2 and 0. So we are at an index of 2 and 0. And what is there in our this empty string? Firstly we have added D, and then again what we have added? We have added D and then again D. Got it? Now what is there? Like from here we can again have four different cases. We either can go to D, or again we can go to our L position, or again we can go to our U position, or again we can go to our right position, right? Now while checking for D, what you're gonna see is, while choosing D, there's 0, so we cannot go to D, right? Now choosing for like this one is not possible. Now choosing for L, what you're gonna see, there's no such conditions to go to our left direction. So L is again like we cannot go. Now for checking upward direction, what we gonna see, this position is already visited. So this is a visited position, so we cannot go back to this visited position. What we need to do is, so like up is also not a visible place here. So now what we can see, like we can only go to this right position. So from here what we're gonna do is, we will go to this index, that is 2 and 1. So we will be at 2 1, and at like in the string where we are adding those things. So what will be the thing here? Like D, after D we have again added D, then again what we need to add? We will add right here, right? So this is the way we'll be proceeding. Now what the thing is, we can like wonder like how we will understand that this is a visible place or not. For that reason what we can do is, we will just simply initialize a blank matrix of the same size, and here like this will be we can do like, we can just give a type of boolean to this place. So initially we will like simply initialize every position with a false. Okay, like every position we will just initialize with a false. And while we will be starting with a backtracking, when we will be at the first position, so simply we will just give a tick, or we'll just cancel this false and make this one as a true, and this is how we can just simply proceed, right? So after this position we will move to this position. So then again we will, what we will do, we will just set this one as true. Then again we'll move to this position, we will again initialize this position as true. So then what will happen, when we will try to move to upward direction, or like from here if we will try to move to upward direction, what we gonna see is, this position is already like it's a visited position, so we cannot move here. We need to move to this false positions, right? So we cannot move to this position again. So automatically we will move to this position and set this one as true. And while backtracking, what we're gonna do is, Suppose think we have got one solution, we have reached to our destination place, and then what we need to do, see which will be set as true, like yeah, this all things will be true. After that this one gonna be true, and this one gonna be true, and this last one also will be true, right? So this will also be true. Now what we're gonna do, like this is one of the solution that we have got. Then while backtracking, while moving to the like, while going to our next place, so similarly what we're gonna do is, once we are here, we'll simply keep on backtracking, right? So while backtracking, what we're gonna see is, suppose this is our place where from where we need to start one another string. So simply while backtracking, when we're gonna see that this place will not serve as a feasible condition, this place will not serve as a feasible condition, we will simply move back and set this position as false. We will simply move back and set this position as false. Similarly, we will just set this one as false, this one as false, this one as false, and this one. From this position we will see that can have another position, like we can move to R. Then if this one is initially false, what we gonna do, we gonna set this one as true, and then again we will start our traversal. This is how we will just initialize backtracking in this place. Now let us check with the code, and while solving the code I can assure you will have a clear concept solving this problem. So basically what we are seeing that we need to return an array list string, right? So similar thing as we have done for permutation, combination. If you have not checked those videos till now, you can just check them in my playlist, you will see there. And now what you're gonna see is, we need to return this one, so we can just set this one as like anyone. I will just give this one as result, and we will just create a new array list here. And simply return this array list, right? Now let us think that what can be the things that we can do here. So basically what we did, we created a complete, so you can see here, we created a complete blank boolean type matrix, and that is also of the same size n and n, right? So what we're gonna do here is, we will create a boolean matrix, and we can name that one as visited or viz, anything. I'll just name it as viz, and I will create this one. So this one is created, right? So now what we're gonna do is, we need to calculate things, right? We need to solve these problems. For solving that problem, we need a function. We can name this one as, I'll just name this as solve maze. And inside the function, what we're gonna send, we're gonna send this matrix that is given to us. We'll send this one first. So firstly we'll send m. What we're gonna send next is, like, what we're gonna do now is, we need to send this result even, right? We need to send this result string also. Then we need to send this newly made matrix that we created right now. We need to send that one also, right? Then what we need to send is the length of the the length of the matrix that is provided to us. We need to send that one also. And now what we'll send the row number and the column number. So we're gonna send row as 0, column as 0, and complete blank string where we're gonna add, right? So we'll send this one. These are the things that we'll be sending. Now let us create this solve maze function. To create this solve maze function, similarly we're gonna say is public static void, and we named it solve maze, so we'll just give that name as solve maze. Now just have to fix the parameters that are here. We need to fix the parameters first. So yeah, this is like aim is a matrix, so we're gonna name this as aim only, no issues here. Then what is there? The result is there, so that is what it's array list trace. So similarly we're gonna add this one also here. Now what we're gonna do, we're gonna add this boolean empty matrix, that is of type boolean. So we're gonna add that boolean empty matrix here even. Now what are you gonna add? We're gonna add n. So this n value will be also added here. Now what we're gonna do is we need to initialize a row count and a column count. Like we need to find the indexes, right? So to find the indexes, what we need the row number and the column number. We can name this one as R and C. Now what we need a blank string, empty string. So we can name that string as anything. I'm just naming this as P. So string P. These are the things we need here. Now what the thing is, when we will stop, see here, when our R and C both will reach to n-1 position, that time we need to stop, right? And when we need to stop, if the value of like the matrix R and C, if it is not equals to 0 and it has reached to this, like if it is 0, then definitely it has not reached to our, like where we need to go, where what is our destination, definitely it has not reached to that place if it is 0. So if it is 1 and the position is n-1 and n-1, then only we can stop. So our best case gonna be if r equals to if it is n-1 and if c equals to also n-1, and what we got that if that position is not 0, so m of r and c not equals to 0. If this is our condition, then only what we're gonna do, we're gonna like add our strings to our final result. So what we're gonna do is raise dot add, whom we're gonna add, we're gonna add our strings to this result and we're gonna simply return. Done, right? If this is not the condition, like what can be the condition? If r is greater than or equals to 0, means if r is 0 or more than that, if c is 0, like if c is at position 0 or more than that. Similarly, if r is at position 0 or more than that, c is at position 0 or more than that, and if the value of r is less than n and if the value of c is also less than n, means what, like we know that the n is the length of this matrix. If the value of r and c is 1 less than that, like if this is the condition, then we're gonna like start with our entire back traversal and everything, right? So if r is greater than equals to 0 and c is greater than equals to 0 and r is less than n, then and what the thing is, c is also less than n. If this is the condition, then what we can do is, like we will again do one thing. Initially we know this one, what we have done, like we have set this entire thing as false. Like now if we'll see that this one is already being pre-initialized as true, and if it's a 0 found there, simply what we need to do, we need to return from there. Like we have nothing to do, because if it's previously been true, and then we cannot traverse to that place. If it is 0, we cannot traverse to that place. So what we're gonna do is, we're gonna check if visited of r and c is equals to, if that's a true, and like if it's a true or any of this, if it is a true or it is like we can see 0 in our matrix, original matrix, simply we will return, because we have, see, let's write it also, like we have nothing to traverse. We'll simply return and we'll just simply add, and that will be an answer, right? If this is not the case, what we gonna do? We gonna initialize, like, think that if we are here, if we are already here, then we will simply change false to true, right? We will simply change false to true and we will start our traversal. So we will be at R and C, and we will start with our traversal, right? Now we will start with our backtracking. So what the things will happen at backtracking? First thing we need to return is aim, then what we need to return is res, then what we need to return is visit, then what we need to return is in. Now what the thing is, when, like, we need to now think of the position of R, C and aim, right? So when down can happen, we are at this position, that is 0 and 0. When we are moving to, where we are moving to 1 and 0, that is the only place when we can say that yeah, we moved down. Because if we are going to 0 and 1, that time we need to say that we are going where, we need to go, we are going to a right direction, right? So while going to down direction, what we need to say is, yeah, see, what is happening? The row value is been incremented by 1 and column is remaining same. So what we're gonna say, if row, like, while going down, row value will increment once, and what will happen? Column value is same. If this is the case, then what we are adding with P, we are adding here D, right? This is the condition for down. That's an important case. Like if the R value is like R plus 1 and C, then we are adding D. Now you can think like what will be if we are going upward direction. That's simple, like that will be exactly opposite what we did now. If we are at this position, if we need to go up, the column value will be same, it's a 0 column, right? So only the row value will be decremented for up and incremented for down. So what we're gonna do is, you can simply copy this one, and only what will happen, the row value will be decremented by 1, and we gonna we gonna just print here up, right? So this is the condition for up. Then again, think of the condition that can happen while we are going to a right. So similarly, while going to a right, check a row value is like it's the same value. What is incrementing? The column value is incrementing, right? So what we're gonna do here is, row will remain same. Row is R. Only the column value will be incremented by 1, and we're gonna just print R here. So this is for our right. And for left, row value will be same. Like if we are at this position, if we need to go to this position, row value will be same, right? But like column value will be decremented by 1, right? So for printing that, what we need to do, row will be same, column will be decremented by 1. This will be the case for left, right? After these things have, like we are done with these things, what we need to do, we need to reinitialize visited as false for facilitating our backtracking, right? So visited of R and visited of C will be initialized as false. So this is the entire case of a rat in a maze. Now let us check if there is any error or not. If there is any error, we'll fix that also, no issues. So here one problem is happening, that is, yeah, I have not initialized the value, like I have not set the value of this boolean this matrix. So I need to set the values. I said no, that it will be same as, see, this size and this size is exact same, so it will be also of size n cross n. I need to set this value. Now let us check if any fault is there or not. Okay, so here one issue is happening, that is my string is adding an extra space between. So you can check there's a space between this R and D. So my function is adding an extra space between them, right? And no space is here. You can see this is a problem. So what I need to do is a simple thing. I just remove the space between my string, like simply remove a space between this, and it will be completely fine, I guess. Now let us check if any issue is there or not. Now let us just submit the program and check if any issue is happening with any test case or not. Yeah, so all the test cases are successfully completed. So now what the thing is, this is the way we can solve this problem of rat in a maze, and it is one of the a very frequently asked question from matrices. And yeah, that's all about this video. If you like this content, just give me a like, motivate me for making such videos more. Subscribe to my channel and just let me know in the comment section which problem solving you just want in my next video. And thanks, that's all for today.